First, you need to go to my homepage, that is pskana.com. After that, just right click in the machine learning using Pycaret. And if you click on this link, you will redirect to my GitHub homepage. Okay. So this is all about the notebook that is residing here. And there are 3 notebooks for regression, classification, and clustering. So I hope everybody is familiar with the basics of machine learning. Okay, there are 2 types of problem: classification, supervised and unsupervised. Unsupervised, nothing is the clustering. And in the supervised, there are 2 types of problem: regression and classification. So let me post the instruction again in the chat. Okay. Shall start karte hain. So class, before moving forward, this is the topic today I'm going to cover is Pycaret. So Pycaret is nothing but a Python library. So it is a bundle of multiple machine learning algorithms. Okay. And only 3 lines of code is required to compare nearly 20 machine learning models. So building a machine learning models is very, very simple by using Pycaret. So today we all are going to practice how exactly we need to upload my data, give my data to the Pycaret, how exactly we need to compare on different evaluation parameters. Okay. So now, in today's session, we are going to learn about how to create the model, how to tune the model, predict the model, save and share the model. And these are the 3 lines of code that is required. Okay. So this is just a very brief introduction about Pycaret. Okay, we will do the hands-on practice. So, but the important thing is that if we are working with regression model, okay, in regression the outcome is of real type, continuous value are there, okay, target column. So by running Pycaret for regression, we will get this type of result. Okay, so first we need to clear key what is the outcome of Pycaret. So it will compare nearly 15-16 models on different evaluation parameters. Okay, like mean absolute error, mean square error, root mean square error, R square, and 2 other parameters. So this is the outcome for regression. Okay, and this is the outcome for classification model. So in classification, if your data is of discrete type, means if it contains only 2 values, let's suppose 0 and 1, then this is an example of binary classification. If it contains more than 2, then that will be considered as a multi-class classification. Okay. So if you have any question, query, you may ask, or let me paste the chat instruction again in the chat. Yes. So this is the outcome for classification. Okay. So in classification, there are different evaluation parameters like precision, recall, AUC curve, sensitivity, specificity, F1 score, kappa score, and accuracy. So it will arrange all your models on the basis of accuracy. Okay. So this is for classification. And next and final last one is for clustering. So clustering is nothing but an unsupervised learning where it contains only set of features, no target column is there, and we need to make the clusters. So there are few algorithms like k-mean clustering, hierarchical clustering, and k-mean shift clustering, and we need to compare on different evaluation parameters on different number of clusters. Okay, so this is the summary for today's work that we are going to cover. So before moving forward, let me share the instruction again. First, you need to go to my homepage, pskana.com. Okay, this is all about my homepage. And just click on the third part, machine learning using Pycaret. It will redirect to my GitHub homepage. And there are 3 notebooks: Pycaret for regression, Pycaret for classification, and Pycaret for clustering. So first we will work with the regression part. So I'm requesting all of you, just right click, open in a new tab for regression. Okay. So it will just open like this. And there is a button with the name Open in Collab. Okay. So I'm requesting all of you, just first I am just exploring what is the outcome, and after that we will go for the practice session. So this is all about the Pycaret, and these are some tutorials, documentation about regression. These are the things that we are going to learn in this practical session. So first, we need to install Pycaret and get the version. Okay. So there, all the instructions are well written and well documented here. Okay. So if you don't know how to work on Pycaret, sorry, on Jupyter Notebook, no issues. So क्या करने का? You need to just click on Open in Colab. Just click on Open in Colab. If you want to change your login, you can change. Yes. So class, this is all about we are start working on regression on Google Colab. So if you don't know about Google Colab, it is one of the online platform for running Python program through Jupyter Notebook. So those who are working in machine learning, deep learning, they must be familiar with how exactly we need to work with Jupyter. Okay, and they must be aware about Google Colab. So all the execution of your program will be done at the Google server. Okay, so there is no need to install any software or any IDE for Python programming. Okay, so class, if you have any question, query, you may write in the chat also. Okay, no issues. Let me paste the instruction again. Chaliye. Now let's start. So class, there are only two things that you need to do. This is a gray color code shell is there. There are two type of shells, code shell and text shell. So let's suppose this is a text shell. If you double click it, so it will be written like this, and this is the outcome. So if you want to come out from this, just press Control Enter, or just press anywhere outside this box. And this is a shell. This is just a code shell. Okay. So if you want to execute the code shell, there are two options. Number one, just click on this button, or just press Control Enter. Okay. So I am just pressing Control Enter. Now again, it is asking for, it is not Google authorized. No issues. Just click on Run Anyway. As you click on Run Anyway, just see here, it is start connecting to the Google server. It is initializing the resources. It is now connected, and these are the RAMs and disk that is assigned to this particular session. So it is just a first step is to install the Pycaret library. So those who are familiar with the Python, they know how to install any package in Python. So pip install Pycaret. But I am installing in the Jupyter Notebook or Colab, you need to put the exclamation sign. Okay. So there are some intermediate results I don't want, so I redirect to a null directory. So class, this is the very first step. We need to install Pycaret. Now, if you're working in your Jupyter Notebook, in your local, okay, if you're working in your Anaconda, so you need to install for only once. But if you're working in Google Colab, then you need to install again whenever you want to work. So now almost it is done. Yes, perfectly done. So class, just press Control Enter. This library, it automatically install Pycaret to your Google Colab. So this is the very first step, we need to install it. Okay. So I hope everybody done. So let's move forward to the B. So we want to know which version of Pycaret we are working. So just press Control Enter. So in this, we are importing a function with the name version and from pycaret.utils. So class, this is the two things that you need to do. So this is the latest version that we are working with the Pycaret, and after 15 or every 1 month, they release the new version. Okay. Let's suppose if you install the Pycaret after 1 month, so there might be a possibility you may get the different versions. Okay, so this is all about the environment setup. Now next step is come to step number 1. So class, all the things are well written and well documented. Okay, so get the list of data set that is available with the Pycaret. So there are nearly 55 data set that is available. So क्या करने का है? Just click it, just press Control Enter. Okay. So now from Pycaret.dataset, I am importing a function with the name getData. So this is a function name, and I am just passing index. So it will return a list of data set that is available with the Pycaret. Okay. If you explore in, if you just scroll it down, you will find nearly there are 55 data sets. Now, just let me briefly explain about the data set part. Okay. So this is the name of the data set. This is the type, multivariate. So class, there are two types of data set, multivariate and univariate. I hope everybody knows what multivariate or univariate is. If one input, one output is there, then that is known as univariate. Okay. Example is OTP. Okay. For every transaction, there is a one OTP. So one input, one output. Okay. So just remember this. But in real life examples of machine learning, 99% data set is of multivariate type. Okay. So means that contain multiple input parameters and one output. Okay. What is a default task? So there are multiple tasks that we can perform, like anomaly detection, association, rule mining, classification, okay, classification, binary class, multi-class, clustering, okay, and similarly, in the end, we can perform NLP and regression. Okay. Now, next is target column. Okay. So you know very well that if my data is of supervised type, then that must contain the target column. Okay. So that may be if discrete value is there, then that is a binary classification problem. And if it is a continuous value or discrete value, real values, so that is considered as a regression problem. Now these are the number of instances, means number of rows, number of attributes, and it contain any missing value, yes or no. So these type of data set that is available with the Pycaret. Okay. So now for this experiment, we are working with the data set Boston. So that is available at the 46 number. Yes. So right now we are working with Boston data set that is of multivariate type. We can perform regression, and MEDV is a target column, and 506 is number of rows, and 14 columns are there. Okay. So now just move forward. Come to step number 1.2. So very first step is load the data. Okay. So what exactly I am doing? Get the data Boston. Okay. Just we need to pass the data set. Let's suppose we want to work with the energy part. So just replace the Boston with the energy. If we want to work with the insurance, so just replace the insurance Boston with insurance. So that particular data will be pulled out from the Pycaret library and assigned to this data set. Okay. So class, if you face any issue, please let me know. TrankGen, it is very simple here. It is, you can open in the Google Colab. Perfect. So those who joined late, I just again send the instruction in the chat. So it is very simple. Just go to my homepage psghana.com, and in the right hand side, machine learning using Pycaret, click here. Okay, and it will redirect to you my GitHub homepage, and after that you need to click on regression notebook. Okay. After that, just load the Pycaret. If you are not able to see, kindly refresh it, and just there is a button with the name Open in Colab. Okay. So this Pycaret notebook will appear. Okay. So class, this is the very first step. We are getting the data set. So press Control Enter. So what I did here, I just load the data and shuffle it. Okay. So now this is just a glimpse of the data set that contain multiple columns, and last column MEDV is my target column. So you clearly see it contain continuous values, means discrete real values are there, decimal values are there. So that's why this is a data set of regression. Okay. So class, this is step number 1, loading the data set. I told you earlier only 3 lines of code is required to compare 15-16 machine learning models. So now building a machine learning model and comparing them, it's become very, very easy. Okay. Now come to step number 1.3. If you want to download the data set to your local machine. So first, uncomment, remove the hash. So first step, what I did here, I just convert to the CSV file, and then I import some function from Google Colab, and I call it files.download. So this file will download. So just first uncomment the third line, press Control Enter. Okay. So this is the way you can download the file to a local machine. Okay. So let me save the file. The file is saved. So class, this is very important. Whenever you want to download the result from Google Colab, so this is the way. Okay. So class, come to step number 1.4. Okay. So this is the step number 2. Okay, class, I told you 3 lines of code. So first is data. Second is this line that I'm going to explain. So we are working with the regression. So first we are importing Pycaret.regression, and we want to import all the functions. Okay. Now there is a function with the name setup that require 2 mandatory parameters, like what is the data set name. Class, just give me 1 sec. I'm just returning back. My screen is getting disturbed. Okay, I'm back. Let me paste the instruction again. Okay, chaliye. So class, just come to the step number 1.4. So where we are working, we are just call a function setup that required 2 parameters. Number 1, what is the data set name, and what is the target column. Okay. Now these are the some parameter, like what if we want to change the training testing partition. So by default, what exactly we do? So we keep that 70. Let's suppose this is 100% data. We keep the 70% data for the model building, and we test on the remaining 30%. So I hope everybody understands this concept. Now, if we want to shuffle the data set, or we want to disable the data set shuffling of the data set. So data split shuffle equal to false. So it will not shuffle the data set. Okay. So just press Control Enter. Class, if you are not able to run for the next step, just take care if you properly run the previous step. Okay. If you skip any of the step, then you cannot run the next code. So class, we call the function with the name setup. तो क्या किया इसने? It required only two parameters. Number one, data set that we just read in the above step, and what is the target column name. So these are the two mandatory things you need to perform. So class, now what setup function did? It set several parameters. There are multiple parameters that is set. Okay, and I will explain all the steps in 3-4 after 5 minutes. Okay, so class, this is step number 2. If we set the parameter for my Pycaret. Next, and this is the last step, run and compare. Come to 1.5. We are just calling a function with the name compare models. So just press Control Enter. So it is running multiple models. Now it is done. So you clearly see that my R square is 0.89. So class, these are the evaluation parameter for regression model. Okay. Now it compare all the machine learning models on different evaluation parameters, and it sorted on the performance on the basis of R square value. Okay, class. So now I hope everybody understand that building machine learning models and comparing them is just a matter of 3 lines of code. Okay. So if you have any issue, please let me know. What is the need of shuffle? Very good question. Let me explain with example. Why exactly we need the data and we need to shuffle the data set. Class, why exactly we need to the need of the shuffle? So just see here. So this is a small data set, okay, and I put the data set for classification for model building, okay, and there is a 10 rows. So I build 70% data for training part. Let's suppose this is for training, and this is for testing part. Okay, this is for training part and this is for testing part. So there might be possibility that my data set is arranged like this. Okay, now if I didn't shuffle it, then what happened? You clearly see all my ones and only single zero will go to the target column. Okay, yani data is imbalanced and it contain all ones, and in the testing part no one is there. So that's why we need to shuffle it. We need to send the same amount of data of both the classes in the training as well as in the testing. Okay, so that's why we need data need to be shuffled. चलिए, so I hope यहाँ तक आप सभी को समझ में आया है. Class, please write in the chat yes or no. Is that called stratification? I have no idea, Tarun. What is stratification? Yes, what is R square? Very good. Let me explain what is R square. R square is nothing but the square of correlation. So class, in the end we have two values. One is actual value. Actual value is nothing but the target column of testing data, and predicted value through models. So we got two values. Okay, and we need to calculate the correlation. So correlation values lies between -1 and +1. As it come to 0, okay, let's suppose 0.5. So means this data set is just similar to 0.5. 50% similarity is there. So a good correlation considered as 0.8 or 0.85. that will be considered as a good correlation. Means actual value of and a predicted value through model are almost similar. Okay, but correlation value may be in the negative -1 and also in the +1. Both are good, but as it reaches to 0, it gets poor. Okay, so take an example. Let's suppose I want to compare two objects. This is a key, this is a mobile. Okay, so let's suppose I calculated the correlation between two objects and I got to know that the correlation is let's suppose 0.1. So 0.1 is a very poor correlation. Okay, so let's take another example. Let's suppose there are two keys. Okay, one key and another key. So there is some correlation is there. So let's suppose 0.7 or 0.8 correlation is there. So I can think, yes, at least that contains some correlation. Similar value is there. Okay, and to make it positive, we need to just calculate the square of the correlation. So R square is nothing but the square of the correlation. So that's why that value contain only positive value. But in Pycaret, you can also got R square value is negative. So this is somewhat bug is there where it is not able to calculate the R square. Okay, so it should not be in the negative part. Okay, any question, query? Okay, perfect, very good. Chaliye. So class, this is all about how exactly we need to run the Pycaret. Now next, let's suppose you want to work on 3 line of code, just 3 line of code you want to work on your insurance data set. Okay class, so these are the 2 libraries that we need to import. I am just getting a data set insurance, and these are the two parameter that we need to set. Okay, what is the data set name? So this is a data set name that contain insurance data, and this is the target column. So just press Control Enter in 1.6. So it is executing, and it will generate the result in next 20 seconds. It is running. Yes, it is done. Okay, so just see here on insurance data set, I am getting the R square value is 0.85. Okay, so this is the way we can run multiple machine learning models, because whenever you are writing research paper or you are working on your thesis or you want to show some presentation, then this type of comparison we need to compare, we need to show. Okay, so now in the back end class, just try to understand how exactly Pycaret is working. So Pycaret is in the top, but in the back end, all the libraries that is available in the scikit-learn, multiple algorithms are available in scikit-learn library. So they just merge, make a bundle, and just 3 line of code, we can call all these functions and just got the result like this. So nowadays, building a machine learning model and comparing them, it's become just very simple. Okay, so hope everybody is get the point. Okay, now just move to 1.7 part. Next line. This is the same code for house. Okay, you want to work with the house data set. Okay, so in house, so first import the data. I am getting the data set. Then we need to set the parameter for setup function. So in setup function, we need to set the data set and what is the target sales price. So just don't execute this line. You will get the result like this. So we are getting the R square value is 0.86. Okay. So this is the way we can compare multiple machine learning models in just 3 lines of code. Okay, perfect. So those who are joining late, kindly follow the instruction. Hi, Preeti, we are just working on how to import your own data set. Okay, so just come to step number 2. Just come to step number 2, working with the user data set. So class, let's suppose you want to work with your own data set. Okay, so just come to 2.1. So very first step, you need to upload the file. So just uncomment 2.1. So I am just importing a library and I am just uncomment and press Control Enter. So now Google Colab is asking for upload the file. So let me upload the file that I just downloaded, Boston dataset again. So just browse. Class, this is very important. Okay, let's suppose we want to work with our own data set. The first step is upload the file, and this is the way. Now just see here, saving the Boston file to this one. This is the important thing, because right now it is just uploaded and the file name in the Google Colabs is Boston dataset 1.csv. So just copy it. Next step, to read the file. First, come to step number 2.2 and change the file name here. Okay, class, I hope everybody is getting. So reading a file, we are using pandas. Okay, this is the file name that is uploaded in the Google Colab. So pd.read.csv and assigned to my data set. And I am just showing head. So press Control Enter. Now it is done. Okay, so this is a data set that is just loaded to the Google Colab. Okay, so class, there are 2 steps. Number 1, uploading. Number 2, reading. And now come to step number 2.3. Uncomment both the lines. Okay, and data set name is my data is okay. Target column MEDV just copy karo and just change it here target mein. Okay, so this is the only change you need to make. Apna target column hai aapko. This is a data set in which your file is loaded, and just press Control Enter. Okay, so it will take nearly 20-30 seconds. So I hope everybody is understand how exactly we need to compare and working with our own data set. So those who are joining late, I am posting the instruction. If it is showing some error, then please check your data set. Okay, chaliye. So now it is done. Compare the model 2.3. Okay, so this is the way we can work with our own data set. Now, just come to step number 2.4. Let's suppose you are working in your Anaconda or Jupyter notebook in your local machine. Okay, so this is the way you can work. Okay, just put the data file name. Let's suppose this is the data file, and just put the data file name where your Jupyter notebook is residing, and you both should be present in the same folder. Okay, so just uncomment and run it. So no need to upload and read the file. Okay, so this is all about working with the data set. Now, so class, before moving forward, if you have any issue, question, query, you may write in the chat. Under upload step, browse option not showing how to upload. Yeah, just see here. I am just executing 2.1. I am just executing. So it is showing browse. So first you need to browse the file. And now it is done. कुछ नहीं करना है. It may depend on the file size also. Let's suppose you are uploading a huge file, then it will take time. So just wait. Okay. So this is all about the working with the user data set. Now come to step number 3. Class, that is very, very important. Okay. Right now, all the things that I just explained, it is just a easiest way. If I explain to a 7th class student, then he can also understand what exactly going here, how to compare the models. Okay, but that is not a machine learning, that is not a real machine learning. ठीक है, तो क्या करना है, कैसे करना है, let me explain again. So class, let's suppose if somebody asks to you how exactly you can improve the performance of a model. Okay, let's suppose you have some data and you are getting 70% accuracy. Your accuracy is not going to increase. Okay, so in that condition, what exactly you can do to improve the performance? Okay, so class, there are two ways to increase the performance. Number one, data pre-processing. Okay, that I am just going to explain. And step number 2, you can tune the model parameter. So by doing this way, you can improve the performance of the model. Okay, so okay, done. So class, let's make some pre-processing part and compare the model performance. Okay, so very first is come to step number 3.1. We want to make the use of normalization. Okay, what is the effect of normalization on the after applying the machine applying the normalization on the data set, and then we need to compare the model. So what is the effect of the normalization on the model performance? Okay, so class, it is very, very simple. So we need to set only 2 parameters: normalize equal to true and normalize method equal to z-score. This is the only 2 new parameter that I just added. Okay, so class, I will explain all these things. What are the different parameters? How exactly we need to call the parameter, and how exactly what are the different options are available. Okay, so this is the only things that we need to do. But before moving forward, let me explain the normalization. To bring down all the parameter in the same range. Take an example. Let's suppose I have 4 columns: age, salary, let's suppose age of a person, and weight of a person, and height of a person. Okay, so height, weight, salary, age, and kya tha ek aur? Let's suppose 5 parameters are there. So every parameter having some different range, lower bound or upper bound are different. So if I normalize them, so all the value can become in the same range. So there might be possibility that model can perform better. So let's just run this code 3.1. So we are just running the code, and we want to check what is the effect of normalization on the model performance. And you clearly see how simple it is. Otherwise, you need to write another program that normalize your data set. After that, you need to compare the model. Okay, so just see here, we are getting the R-square value is 0.89. Okay, now there are different normalization methods like z-score, min-max, max absolute, and robust. Okay, so these are the other methods that you need to try. Our ultimate objective is to maximize R-square. That's it. और कुछ नहीं है अपना. ठीक है? So it is now just become a parameter. Just parameter value change करो. That particular operation will be executed. Okay. So now just see how simple it is. Okay, so now move forward. Come to step number 3.2, feature selection. Let's suppose we want to apply feature selection. So class, let me briefly explain what feature selection is. Let's suppose there are 100 features, 100 columns are there. Okay, and feature selection is that we need to select some features that are important, and after that we need to build a model. Okay, and that model will able to give the better accuracy than the previous one. So if in a single line I want to explain what is a feature selection, so feature selection is a dimension reduction data set. Sorry, dimension reduction process. Okay, earlier we are using 100 features, and right now we are using just only 20 features. And next is what is the advantage of feature selection? Okay, what is the advantage of feature selection? This is very important. So there are two advantages. Number one, as you see, data is reduced, model building will become fast. Okay, and second advantage, whenever a new object will come, so rather calculating 100 features, I am going to just calculate 20 features. So these are the two advantages of feature selection. Okay, earlier we are just reducing the data set to 20 features only, so that my model will become faster. And next, if any new object will come, only 20 features we need to calculate rather than 100. So these are the two important advantage of feature selection. So class, for feature selection, we need to set three parameters. Number one, very first step is feature selection equal to true. Feature selection method classic. And there is a feature selection threshold is 0.8. So these are the three things that we need to set. Okay, just wait for 4 more minutes. I will explain how we get to know what are the different features, what is the different parameter available, and what are their possible values. So just let me cover these things, then I will let you know. So first, feature selection true, feature selection method classic, and feature selection threshold is 0.8. Got it? Now, also there are another method for feature selection is Baruta. So just replace with Baruta and just execute it. Just execute step number 3.2. नहीं 3.2 में आपको uncomment नहीं करना है. It is just an instruction कि what are the different feature selection methods are available. Okay, so just see your R's value is getting 0.89. Okay, so this is the way we can apply feature selection. Next, outlier removal. Okay, so class, outlier removal, outlier means the extreme value on the either side. Okay, everybody is most of you know what is outlier, but let me explain with a very small and simple example. Let's suppose there is a class of 50 students. So salary of a teacher and pocket money of a student. Okay, so obvious baat is the teacher is become outlier. So the outlier is just that basically our data should be present in the uniform distribution. Okay, and the value in the left hand side or in the right hand side, that will be considered as a we can remove that value. Okay, so now how exactly we need to apply outlier? So first, remove underscore outlier equal to true, outlier threshold equal to 0.05. So 0.05 means 5%. Matlab we need to remove the 2.5% from the right and 2.5% from the left. You can increase this value also. Okay, so let's suppose we are getting, let's execute it. Now it is done. So just see here, my R square is getting somewhat lower. Rather than it is getting 0.88, but earlier we are getting 0.89. So there might be possibility a particular data pre-processing step may not improve the performance. Okay, chaliye. Come to step number 3.4, transformation. So class, transformation is nothing but one of the replacing the value. So just let me explain with example. Let's suppose there is a one column is there that contain 1000 values, and all the values are lies between 1 and 500. 1 and 500, 1 and 500, 1 and 500. Okay? Any value data can contain. So now what transformation means, okay, let's suppose I created my own rule. Okay, if the values lies between 1 and 1 and 100, assign as 1. Okay, 100 and 200 assign 2. 200 to 300 assign 3. 300 to 400 assign 4. And 400 to 500 assign 5. So I convert all these real values to discrete value. Only 5 value are there. Okay, so that is known as binning. So binning is just one of the example. So where I convert my data set to number of bins. Okay, so now how exactly we need to make it? So transformation equal to true and transformation method equal to Geo Johnson. So just run execute step number 3.4. Press Control Enter. Jasprit, performance of model using Pycaret increase or decrease when compared with other using algorithm directly without using Pycaret? No, it will not change. It will not improve because in the backend your scikit library is used. But if you are using different library, then you may get the difference in the result also. Okay, let's suppose you are working with the in the MATLAB. Okay, and this is implemented in Python. Okay, so if you try to run the same model, let's suppose gradient boosting regression model is there. Okay, and that is implemented in Python also, in Java also, R also, and MATLAB also. So there might be possibility you may get the different result of the same algorithm because that is implemented by the person like me and you. Okay, and all the 4% may not write the same code. Somewhat little bit difference may be there. Okay, so there might be a possibility you may get the different result. Okay, so this is all about the transformation. Next, 3.5 PCA. Class, this is very important. Everybody know about PCA, the principal component analysis, that is just used for reducing the huge amount of data, huge amount of data reduction. So class, let me explain. PCA is the principal component analysis in which we are going to reduce the data set, reduce the dimensions of the data set. Now just let me explain with the example. Let's suppose I have one figure, one image is there of 100 by 100 pixel. 100 by 100 pixel, okay, and I want to convert to a 1 by n square vector. So 1 by 10,000 features are there for single image, okay, because one array is there, one row is there, so just just take the second row, put in the end, third row, fourth row, fifth row. Is to say we are just and converting n by n square matrix to 1 by n square matrix. Okay, so now the matrix, the length of the vector become 10,000. So let's suppose I have 5,000 images. So just imagine how huge my matrix is become. 5,000 by 10,000 matrix. And no algorithm is able to build on 10,000 features. Okay, so in that case we need to reduce the dimension. So earlier when we are struggling with the hardware, we don't have the GPU, we don't have the strong machine, we generally use the Pycaret PCA and that time. So that will reduce the 10,000 features to small number of components. Okay. So let's suppose 5 components are there, or 6, or maybe 10 there. So just my data is reduced to 5 columns only, or 10 columns only. That will consider as a new features, and 5,000 features are there. So it is extremely used for dimension reductions. But right now, nowadays we don't have the limitation of hardware, RAM, processors. So we don't use PCA nowadays. So in the mathematics, if you want to calculate the PCA, so PCA eigenvector is there, eigenvalue is there. Just explore any YouTube video, you clearly explain how exactly PCA works. But that is not our objective to learn the PCA. Our objective is to apply the PCA. So to apply the PCA, just make PCA equal to true, PCA method equal to linear. Okay. So this is the parameter that we need to set. So I am just not executing this code. Just see, my R square value is just 0.38. Okay. So this means that PCA will not work for my data set. Okay. So I hope everybody is understand. ठीक है. PCA आप सभी लोगों ने पढ़ा हुआ है, but no one knows how exactly we need to apply PCA. Okay. So this is the way we can apply the PCA also. Now just moving forward, I'm not right now I am not executing this code. So let's suppose you want to perform 2 operations, like outlier removal and normalization. So what I did, remove outlier equal to true, set is threshold, and normalization equal to true, and normalization method. Yani ki just setting the parameter for both the operations. Okay. So I'm just skipping this part. I'm not executing. Come to 3.7. If you want to perform 3 operations, so just set the parameter for all the operations, 3.7. So this is all about the applying the different PCA. Now let me come to the step number 1.4. Let me explain the setup function. So class, just go back to step number 1.4. Yes. So in 1.4, there is a function with the name setup. Okay. So parameter setting for all the regression models. Okay. So it will, we can apply train test division, applying data pre-processing such as sampling, normalization, transformation. So setup function will contain lot of parameter. So when I call the setup function, so now just see what exactly it is doing. It is setting up some parameters and then it just show to you like shuffle train test false, because I make the false in the parameter itself. Data split shuffle equal to false. So that's why data shuffling is by default false. Okay. Similarly, yes, normalization. So by default normalization is false, and just see normalization method equal to none. Transformation, PCA. Okay. And after that, your outlier threshold. Okay. Multiple other parameters are there. Okay. So just I set the parameter in the setup function. So there are nearly, similarly feature selection. So there are 57 parameters that is just come in the function. So now just check how it is simple to compare and set up the parameter for all the models. Now just come back to step number 3.8. Just right click and open in a new tab. Click here for more. So it will redirect you to the setup function. So this is the setup function that contain all the parameters. So these are the 57 parameters that are available. Okay. So just let me explore the Control F normalization. So this is all about normalization method. तो जस्ट कॉपी करो इसको, just select normalize method, copy, control F, control V, paste and enter. So this is all about normalization method. So by default it is Z score. So now this is the parameter name. Okay class, if you see in the step number 1.4, just see normalize equal to false and normalize method equal to name. So this is not the parameter name. Okay, it is just a representation. Parameter name is normalize and the parameter method is normalize underscore method equal to Z score. So these are the other methods that you may try: min max, max absolute, robust. Okay. Similarly, for the transformation by default is false. So we just set to true, and this is the method name U Johnson, and you can also try for quantine. Okay, so replacing the U Johnson with the quantine, you may get the different result also. Okay, so this is the very good and very important library that gives the information for all the parameters. Okay, now just come back to step number 3.8. So I hope everybody is understand how exactly we need to call the Pycaret. Okay, so class, if you have any question, query, you may write in the chat also. Just wait, my system is getting hang.
Yes, sir.
Class, just wait for one minute. My laptop is not working. Class, just give me 1 minute. I am joining back. I am just rebooting my machine.
क्या
Technical team, please look into the issue.
Okay, Sona ma'am, please wait for 2 minutes.
Thank you very much. Class who joined late, I just sent the instruction in the chat. And sorry for the delay. Just give me 1 more minute, and those who are who can continue, just go to step number 4 and start executing. So this is the only drawback with the Google Colab. So just come to step number 4. Yes. So now just come to step number 4, building a single model. So class, let's suppose we got to know that my random forest model or any other model available that is that is outperform. Okay, that is the best model. Now we want to use that particular model for the deployment purpose. Deployment means we are going to make for the prediction for the online, or we can use that particular model for the prediction for the new data set. Okay, so just we want to build how exactly we need to build a single model. So just come to step number 4.1. So we are importing dataset regression library. After that, we are importing the Boston dataset and set up the parameter. And we are just going to create a model with the name random forest. Okay, so just press Control Enter. 4.1. Now model building is done, and just see here, my model is run for 10 folds. So class, what exactly 10 folds means? My data set is divided into 10 parts. Let's suppose 10 parts are there. Okay, and 7 part, from 1 to 7, it will go for training, and from 8 to 10, it will go for testing. This is one run, and this is the result. Okay, now in the second part, from 2 to 8 will go for training, last 2 and first one will go for testing. This is second run. In the third, 3 to 9 will go for training, and 10th part and the 2 in the starting will go for testing part. The main objective behind k-fold validation is that every time we are getting different result, give different data in the training and different data in the testing. Okay, so just see here. So we are just taking the mean for the R square and we are getting 0.7. Okay, so this is the model building. This is step number 1, and we store the model in RF model. Okay, create model, random forest, and RF is there. Okay, so this is all about RF part. Now, if you want to create another models, so these are the shortcuts like ADA boost, Bayesian widget, decision tree, elastic net, extra tree regressor. So these are the models that you can build. Okay, so this is all about model building, individual model building. Now there is a small tutorial. Just right click, create model. So this is a small create model. These are the small manual for creating a model with different parameters. Okay, next. So now model building is done. Now we want to make the prediction on the unseen data set. This is the important thing. कि नया data अब आया है. Now how exactly we need to make the prediction on the new unseen data. Unseen data means that is not a part of the training part, nor it is a part of testing part. Okay. So right now I don't have the unseen data. So what I did, I selected the 10 rows from the Boston data itself. मैंने data Boston के data set से शुरू के 10 records उठा लिए हैं. So this is the way to get the 10 records from the Boston data itself, and this is the data set, and assign to the variable new data set. So just consider it is a new data set that is not a part of training part or testing part. Okay. So now we are going to use random forest and get to know okay, what is the result for these 10 records. Okay. Chaliye. Now to make the prediction on the new unseen data, there is a function with the name predict underscore model. It requires 2 parameter. Number 1, my train model, and second one is the my data set. Okay, and just execute. I execute. Perfect. If you skip anything, just execute again. I'm executing. So just see here, predict model make the predictions using this model on this new data set. Okay, so I hope everybody understand. And just see here, a last column is assigned with the name label, means this is the prediction value. Okay, now let's move forward, come to step number 4.5. So let's suppose we want to plot the scatter plot, and I consider last value as a predicted value. So I selected -1, and I selected second last value as an actual one. Okay, so this is a very important thing, how to get to know how to select the particular column value. So -1 means last, -2 means second last. Okay, so I just use the matplot library and I just plot it, X label, Y label, title, and save the image and show. So this is all about my scatter plot. So just execute it. It is done. Now, if you want to save the result, means this result, this table, this output to a file. So what I did, new predictions.tocsv. Okay, so just execute it. So my file will be saved to the Google Colab. Okay. Now it is done. Now next, if you want to download, so uncomment it and execute. So you will clearly see I am just importing Google Colab files. So files.download, and this is the file name. Okay, so the same name is there. Just execute 4.7. It is showing downloading. It is asked for the path. To save. Let's suppose we want to save in the one of the folder and save. Okay. So that result file will be saved to your local machine. Now next 4.8. This is very important. Let's suppose you want to save a model to a file. Okay, that is very, very important, because let's suppose that help us to not to retrain the model again. Okay, any model building we did for only once. Now we can share this model to anyone through mail, through pen drive, or any other we can share through Google Drive. Okay, so this is very, very important to save a model. That help us to not to retrain the model again for the new data set. Okay, so class, what there is a function with the name save underscore model. It required only two parameters. Number one, my trained model, and the file name. So just press Control Enter. Okay, my model is saved to a file, and saving the model to file does means we are just saving the weights. Okay, now model saving is done. Now we want to download. Just uncomment, come to 4.9, just uncomment the line, and now just see here my model name is R model file, but the file name actually saved with the name .pkl. So pickle file is there. So just execute 4.9. So this file that contain the model is downloaded to my local machine. It is size is 2.6. Save and done. Okay, class, it is done. Now I can mail this model to you, or you can send your train model to me also. Okay, so that is the thing that we want to explain. Now next is, let's suppose you got the mail. Okay, let's suppose my student is working in Google, and right now I don't have the resources, so I just send the data set. He built the model, he mailed to me. Now what is the next step? So next step is, very first step is 4.10.1, upload the model. Okay, so for uploading, uncomment it, execute. So just browse, select the model file name. So I'm just selecting the model PKL file. It is taking some time because file size is 2.6 MB. So class, first step is uploading. Next step is loading. Load means we are loading the model in the Colab environment. Okay, uploading file doesn't mean ki it is ready for the use. We need to load the file to my local, to the environment. So it is taking time. I am just pasting the instruction. Shabira, it is very, very easy, and you can ask the recording from the organizers, they will provide to you. Okay, now it is 79%. And just remember, whenever you are uploading a file to Google Colab, it may rename to different file name. My file name is this random forest rf file.pkl, but it is saving to 1.pkl. And my file is uploaded. Perfect. Now, next step, to use this upload file. So just copy it, come to 10.2, 4.10.2, uncomment it, paste it here, model name, okay, and there is a function with the name load model. So class, this is very important. Load model will load this file to my Google Colab environment, okay, and I am able to use my train model, that is random forest, again. So just execute and model loaded successfully. Okay, so now done. So now the train model that we loaded, it is ready for the predictions. So क्या करने का है वही काम, predict underscore model rf, because this is the file name, this is the model name that we loaded with the variable name rf model, and new data set. Come to 10.3, 4.10.3, execute. So these are the new predictions through my train model that I uploaded. Okay, so I hope everybody is getting understand. Chaliye. So class, this is all about building individual models, and next it is very important, plotting the train model. Okay, so very first is building 5.1, building any model. So right now I am building random forest. So just execute 5.1. So in this phase we are predicting multiple plots like feature importance, hyperparameter, learning curve, validation curve, prediction curve. So that these graphs will be helpful. You can put these graphs to your research paper, to your report, to your presentation. So very first step is building a model. It can be anything. So come to 5.2, we are plotting the error. Okay, so there is a function with the name plot model. Okay, so that is my model name that is just trained in the 5.1 RF model, and this is the parameter that we are passing. So plot equal to error. So just execute it, and this is the error plot. Okay, so we can use for this plot for the prediction of in my results. Sorry, in my research paper. Okay, come to 5.3 learning curve. So I am requesting all of you, don't run this code. It will take nearly 1 to 2 minutes. I am just explaining. So plot learning curve. I am just passing plot equal to learning. Okay. So now learning curve is that whenever we are increasing the number of instances, so 100, 150, 200, 250, 300, what is the effect on the scoring? Okay, and this score is nothing but the any of the available R square value you can take. Okay, so this is the way we can visualize how number of training instances increases and how my scoring is increases. Okay, so you don't need to no need to run this code. Just I am explaining you. Similarly, another plot is known as validation curve. So just pass plot equal to VC, okay, and actual estimated maximum depth. Okay, so class, random forest is nothing but a collection of multiple decision tree. Okay, so as we reaches how many number of depth, height of a tree we can choose. So this is just a validation curve. Okay, so these plots will help you. You need to use these plots whenever you in your paper or your report. Okay, now come to 5.5. You want to know what is the parameter for my random forest. Okay, so you need to just pass plot equal to parameter. Okay, so just run, and you can see these are the parameters that are set for my decision tree. One of the common and well-known parameter is number of trees. If you are working with random forest, one of the tuning parameter generally we choose number of trees. So you can easily change these number of estimators. So here it is known as estimators. Okay. You can also change minimum sampling leaf, minimum sample splits, maximum samples, maximum leaf nodes. So these are the parameters you can change for random forest. Okay, so this is all about getting the parameters. And now if you want to learn more about plot parameters, this is the help. So just right click, open in a new tab. Okay, so this is all about plotting the different curves when we are working with the different models. Now next step is feature importance. Class, this is very important here. Because let's suppose you are working on any of the problem. Let's suppose cancer prediction. And there are nearly 20 features are there. And you want to know which feature is most important. Okay. So in that case, this will help you and it will show you in the visualized form कि graph form कि हाँ कौन सा feature कितना important है. So क्या करने का है? We are again building a random forest. Okay. And there is a function with the name plot model. Same model is there, the plotting है. But in this parameter, we are passing the feature. Okay. So just see here, as I run it, just run it 6.1. So this is the feature importance by using random forest, and this is the score, variable importance. Class, just remember in step number, I think 3.4 or 3.5, we are using feature selection. So we set the feature score is 0.8. Okay, so if we're choosing the 0.8 means we are just selecting one feature. So we should also try for different features, cutoff. Let's suppose you give the value 0.1. So this is 0.1, so only two feature will select. Okay, so that is very important to visualize ki, what is the importance of every features. So you clearly see these are the two most important features, or you can say RM is the most important features. Okay, but you are getting through random forest. Come to 6.2. Okay, now we are again training a different model, extra tree regressor. So to create a model, ET is there. Just execute 6.2. Now it is done. It is again showing these two parameters are the most important. Come to 6.3, decision tree. So here I am passing DT, executing, and again we are getting two results. Now you may ask you why I am showing feature selection, feature importance using different machine learning models. Because the working of every model is differ from everyone. Some uses neural networks, some using tree-based, some using equations, some using different approaches. So there might be possibility they may calculate the feature importance as per their formulas or implementation. So there might be problem, there might be some issue that they are using different feature as different importance. Okay, so I am just showing you. So this is all about feature importance. And next, 7, this is very important. I told you earlier that there are two ways we can improve the performance of the model. One is data pre-processing and another one is tuning the parameter of the model. So here I am just showing you how exactly we can tune the parameter for higher performance. So class, come to 7.1. Here I am building a decision tree. So to building a decision tree, create model, and I'm assigning to the variable DT model. So just execute. And we are getting the R square value is 0.39. Okay. And you clearly see there is a bug because it's showing me the correlation value is 0.1. And it again, this is due to this value, my overall mean is getting 0.3 only. Okay, so this is all about building a decision tree. हमने model build कर लिया है. After that, we want to know कि what is the parameter for decision tree. So class plot underscore model. I am just passing the parameter model name and plot equal to parameter. So just execute. And this is a list of parameters that is set for the decision tree. Okay, like maximum depth not set, maximum feature not set, maximum leaf not set. Okay, and a minimum sample split 2, sample leaf 1. So these are the parameters, by default parameter that is working with the decision tree. Okay, so now model build kar liya and we are getting to know what are the parameters. Now come to step number 2. Class, this is very important. Please focus here. Tune the decision tree. So there is a function with the name tune underscore model. उसमें अपना trained model हमने pass किया है, and also we are passing the number of iterations. So let's suppose we are passing 50. Okay, and assign to the variable dt model tuned. Just execute it. It may yes or done. Very good. Now just see here. Whenever I am working with the decision tree, it is giving me the mean R square value is 0.39. So when I tune it, I am getting the mean square value, mean value of the R square is 0.59. Okay. So class, there is an increment of 0.2. Okay. So this is the way we can improve the performance of the model by tuning. Now next step, we want to know कि now ऐसा क्या हो गया? What is the parameter? What is the new parameter for the tune model? So what I use, tune model and plot equal to parameter. So just execute it. So now these are the parameters that is set, like maximum depth. Earlier it was none. Maximum feature none. This time 1 is set. Okay. Minimum sample leaf, we are getting 4. Minimum sample split 9. Earlier different parameters are there. Yani ki these are the optimum parameter for set by the tune function, tune model. Okay. So this is the way we can increase the performance of the model. Now next, if you want to learn more about tuning the parameter, tuning the model tuning parameter, so just click here, and this is a wonderful tutorial is given, wonderful manual is there, so you can explore it. Next class, this is some advanced techniques. Master students, PhD students, even faculty may try, but for the BTech UG students only till step is there. But now advanced topics are like, let's suppose we want to select best n models, best 5 models, best 6 models, best 7 models, and we want to make them as ensemble or stacking or bagging or blending. So these are some advanced techniques in which we are merging the result of different models, and the ultimate objective is to maximize the performance. Okay, now let me explain a very simple example. Let's suppose I created 5 different models for the prediction of this key. Okay, one may be random forest, another may be decision tree, another may be linear regression, another may be extra tree regressor, and XGBoost. 5 models are there. Now I am just giving all these models to make the predictions. 3 make the prediction that it is a key, and 2 make the prediction it is not a key. So I am taking the voting. So in the voting, 3 models saying key, so this is the key. So this is one of the ensemble technique. We can merge the output of multiple machine learning models. But the objective is to increase the performance up to maximum. Okay. So you can explore how exactly this will help us and how exactly we need to explore. And the final and last part is deploying the model on AWS or Azure. So class, deploying the model means we need to make the model available to the other user in the form of web service or website. Okay, just make a web browser. Okay, just give the assignment to your UG students or BTech students. They can easily develop the website. Okay, let's suppose I am building a website for the cancer predictions, and there are 10 parameters. So 10 input parameters are there. Just give the email ID and just submit it. Okay, so in the back end, my model will take the input, make the prediction, and mail the result to the particular email ID. Okay, now in the back end, my train model is already available there, and that will be loaded when the new data set will come. Okay, and after that, we just pass the prediction to the email ID. So it means that is the deployment. Okay, so you can also deploy by using, there is a link, you can explore it. And this is all about the Pycaret for regression. Okay, so class, if you have any question, you may ask in the chat also. Okay, no issues. Now, let me give you some more important things, some resources for like what are the things that we can explore in the machine learning. Okay, class, nowadays machine learning is not very big rocket science. It is just only matter of 3 lines of code. But the thing is that how exactly we need to make more data pre-processing. Okay, so there are a few libraries that everyone should know. NumPy is there, SciPy is there, Pandas is there, OpenCV and Matplotlib. Okay, so those who are in their UG or masters or initial phase of PhD, they need to know how exactly these libraries work. Just practice it for 1 or 2 days, and good amount of tutorials available online as well as on the YouTube also. Okay. Now, if you're looking for projects, just go to Google and search for Krish Nayak GitHub. I'm just copy it, paste it in the Google, and you will find this one. Also, there is a YouTube channel for this person. So just click on Krish Nayak and just go to repository. So there are 219 projects are there, and these projects are very, very useful. Notebook is available for every project. Okay, and these projects you can include in your CV also, like malaria detection, deep learning for car brand, okay, image web scraper, deployment flask, feature engineering, car price predictions. So these are the very, very wonderful resources. Nearly 219 projects are there. Okay, so that contain like stock market prediction. Okay, so these can be the mini projects for you. Like if you want to work with image segmentation, the fixed lib library is there. Okay, so these are the projects. I am just requesting you, please explore. And the last important resource is papers with code. Papers with code. Just go to Google and explore it. Papers with code. Okay. Hope some of you know what is paper with code. So it will generate, it will publish, or it is a collection of multiple resources like research papers, code, GitHub code. They list all these recent research in the field of NLP, video processing, image processing. All these recent papers were available with code itself. Okay. And now what exactly you need to do? Just go to browse state of the art. Okay. So papers with code. So class, in this website, you will find all these things are grouped. Okay, they all are segmented. All these different domains in multiple categories like computer vision, natural language processing, medical image, methodology, miscellaneous, graph, time series, speech, playing games, computer code, adversarial, audio, robot, knowledge base, music, reasoning. Okay, so these are the domains that are available for research. And the most important thing is that if you click on see all 1 tasks, just click it, you will get the data set. Again, they are classified into different domains like semantic segmentation, image classification, object detection, domain adaptation, image generation, data augmentation. So multiple domains are there. Pose estimation. Okay. So if some students come to you, just redirect to this website, and this is a wonderful resource for projects. And the important thing is that let's suppose we are working on this topic, semantic segmentation. Okay. So this is all about the semantic segmentation. These are the benchmark data sets, best models, research papers, and their code in GitHub. Okay. These are the data set name and link of the data set. These are the subtasks, and these are the great papers that are available in this domain. Okay. So class, this is all about the resources. So in the next session, I'm going to cover the remaining part, working with classification and clustering. And one more important topic I'm going to cover data generation using modeling and simulations. Okay. So if you have any question, you may ask in the chat also. Okay, no question? Okay.
Excuse me, sir. There are few
Yes.
questions in the chat box, where is regression being used?
Very good question. Regression is one of the problem type. Let me explain with some data sets. Yes. So I'm just showing you what is a regression. So class, this is one of the sample data set. That is a data set of proteins. Protein means my nails, my hair, multiple proteins are there. Okay. And very first column is the target column name. Target means quality of the protein. Okay. So that is the target column. And these are the features name. Okay. And you just clearly see this data, this column contain real values. Okay. So means this is a data set of regression. And the use of regression, there is no such use, but it is just a categorization of the problem. Okay. So if my target column is of real values, so this is a data set of regression, and we can apply regression model in the prediction of RMSD. Okay. जैसा अभी हमने किया है, Boston में किया है, we can also work with this data set also. Okay. Now one more important thing. Just see here, this is the same data set, but what I did here, I make the round off. I round off the RMSD column. So you just clearly see all the values are discrete. So now this data has become multi-class classification. There are 6 values, 0, 1, 2, 3, 4, and 5. 6 values are there. So that is the classification problem. So class, this is very important. If you have a regression data set, you can transform it and you can convert to classification problem. And this is the way you can generate 2 research papers. One by applying regression models and one by applying classification models. Okay. Any other question, query, ma'am?
Yes, sir. There's one more question from Tarang, sir. How can we use it for handwriting recognition?
Oh, perfect. I just share the resources with you. Go to segmentation. Sorry, go to paper with code, and there is a search window. So, if you're working on any domain, just try to find the research papers or data set. Say like handwriting. So you will find there are two papers. I am handwriting and brush. So these are the two resources you can explore. Okay. Yes, ma'am. Any other question?
Yes, sir. One question is there, how to collect data sets?
Very good question. Recently, Google just released a search engine for the data set. Just write down Google dataset search. Google dataset search. So this is just a search engine dedicated to the dataset itself. Let's suppose I am working on COVID dataset, COVID images. Okay. You will find long list of things that is available. Okay. Let's suppose COVID chest images. Okay, so anyone can explore, anyone can just Google it. अरे कहाँ पहुँच गया? Or you can write cancer. Okay, so in the left hand side you will get the data set, and just click it, and you will get the more information about the data set. What is the is it available for public domain or not? Or you may ask for the request. So this is a thing that you can explore it. Okay, long list of data set is available.
So the next question is from Karuna, sir, that how to find which technique we have to use for our data set.
This is known as no free lunch theorem. ठीक है, पहले से अगर हमको पता लग जाए कौन सी टेक्निक हमारे लिए अच्छी है तो बात ही खत्म हो जाए. ठीक है, so we need to run multiple models. After that we need to compare on different evaluation parameters. That is the important thing. Because आज तक no technique is available कि जो डेटा को देख के बता दे कि हाँ कौन सी एल्गोरिथम हमें लगानी है. Okay, so we need to run it. That's why machine learning is getting too complex right now, because nowadays huge amount of unstructured data is coming up. Okay, and that I will going to cover in the next session. Okay, how exactly we need to collect our own data set using modeling and simulation.
So the next question is from Varun, sir. Please explain the uploading process again.
अरे यार, it is very simple. कुछ नहीं करने का आपको. हमने अपलोड कहाँ पे किया था? सेक्शन नंबर 2 में. 2 में किया था हमने अपलोड. यस, ठीक है. सो कुछ नहीं करना है, इसको अनकमेंट करिए. कंट्रोल एंटर. इट विल आस्क, ये ब्राउज फाइल आ गया. जस्ट क्लिक ऑन द ब्राउजर. जो आपको अपलोड करना है वो आप अपलोड कर दीजिए. लेट्स सपोज बॉस्टन डेटा सेट इटसेल्फ. So it is done. It is uploaded. ठीक है. Now upload is done. Now we need to read that file. So it is taking some time. And now it is done. and you clearly see the file name is 3.csv. So just copy करो इसको, uncomment both the lines in 2.2 and I am paste it here. It is still running, so just wait. And execute 2.2. तो पहले ही आपका ये फिनिश होगा, after that 2.2 execute होगा. Okay, so this is the way you can check what is the head means. Just show you the top 6 records of a file. ठीक है, ये बहुत very easy है. Next time. Ma'am.
Participants, if you have any query, please drop it in the chat box.
No, madam, it's okay.
Okay.
Okay, ma'am. Thank you very much. So next session, I think, is at 2 o'clock.
Yes, sir.
Okay.
Thank you, sir. It was indeed a very informative and interactive session. And participants will continue the next session sharp at 2 p.m. So kindly join the next session using the same link. Now,
Okay.
I'd like to request everyone to please turn on your camera for group photography.